Hello everyone, today we are continuing our 2D geometry unit talking about circles. So first we have this circle here and we're going to identify some pieces of that circle. So we have the distance around the circle, and that is what we call the circumference. That's equivalent to the perimeter of a shape, but when we have a circle it's called the circumference. We have the diameter, which is the distance from one point to the other straight across our circle. So it's the distance across our circle. And then we have the radius, which is exactly half the length of the diameter and covers the distance between the center of the circle and any point on the circle. Should also clarify that the diameter is always going through the center of the circle no matter where the points are. Alright, so we say C is circumference, D is diameter, and R is radius. And that is going to be helpful in our formulas. So the formula for the area of a circle is A is equal to pi times r squared, or in other words, I have area is equal to pi times the radius squared. The formula for the circumference of a circle is the circumference is equal to 2 times pi times the radius. Alright, so now we're going to go ahead and we're going to solve for some examples. Example 1, find the area and circumference of the circle below. So I'm given this circle, and I have this marking for my radius, and it is given as 7 feet. So to find the area, I have area is equal to pi times r squared. If my radius is 7, then that needs to go right here in place of r. So I really have pi times 7 squared. So area equals 7 squared is 49, so I have 49 pi. Sometimes you'll be asked to leave your answer in terms of pi, and if that's the case, this is where you would stop right here. But it does not specify, so I'm going to round to 2 decimal points. So I'm going to type this into my calculator using the pi button, or you can use 3.14 instead. So 49 times pi, I have area then as about 153.94. I will also mention, because pi is a number that just continues on forever, no matter what you do, you're going to have an approximation because our calculators cannot put in the entire decimal of pi. Alright, next we have circumference. Our circumference formula is 2 times pi times the radius. So our radius is, once again, 7. So I have 2 times pi times 7, which is equal to 14 pi. 2 times 7 is 14. If I multiply that out 14 times, and I usually do press the pi button on the calculator, so 14 pi gives me that my circumference is approximately equal to 43.98 feet. Alright, so there's my area and my circumference. So that's what happens when you're given the radius. In example 2, it says to find the area and the circumference of a circle with a diameter of 12 feet. So if you're given the diameter, you need to think through what the radius is equal to with the diameter. And the radius is always half the distance of the diameter. So if our diameter is 12 feet, then I can say 12 divided by 2 will equal my radius, which in this case 12 divided by 2 is 6, so the radius is 6. Since I now know my radius, I can take that and I can plug it into both of my formulas. So area is equal to pi times the radius, which is 6 squared. 6 squared is 36, so that is really equal to 36 pi. I'm going to type 36 pi into my calculator. When I do so, it gives me that my area is approximately 113.097 feet squared. Typically I would round to 2 decimal points, but that one won't round nicely, so I'm just going to give you all 3. Alright, now we have our circumference. So circumference is equal to 2 times pi times our radius, which is 6. 6 times 2 is 12, so this is really 12 pi. 12 pi typed into my calculator gives me that my circumference is approximately equal to 37.699 feet. And that one too will not round super nicely, so I'm giving you all 3 decimals. Alright, next we have example 3, which says A circle has a circumference of 24 pi. Find its area. So if it's giving us that my circumference is 24 pi, it might be helpful to write down the circumference formula. So circumference is equal to 2 times pi times r. If I know that I have 24 pi, then what I really have is 24 pi is equal to 2 times pi times r. If I divide 2 pi out from both sides, then I'll solve for my radius, and I can use that to solve for area. So if I divide 2 pi from both sides, the pi is going to cancel, and then 24 divided by 2 is 12, so that means that my radius is equal to 12. And this is not given a unit, so 12 is all we can do. So now I take that 12 and I plug that into my area formula. So area is equal to pi times r squared, so that's 12 squared. 12 squared is 144, so I have 144 pi. When I plug this into my calculator, that gives me that I have an area of approximately 452.39. And whatever that is, the units would be squared if we knew what our units were. All right. Our last example on this page is example 4. Example 4 says to find the area and the circumference of the circle below, and then to leave your answers in terms of pi. So we mentioned this a little bit earlier, but we're going to do this example so you can see what happens when we leave in terms of pi. So I have area is equal to pi times my radius squared. My radius in this circle is given to me as 3, so I have 3 squared. 3 squared is 9, so I have 9 pi, and this is centimeters squared. And that right there will be my answer because I want to leave this in the simplest form without multiplying out pi. And then circumference will work much in the same way. So we have circumference is equal to 2 times pi times our radius, which is 3. 2 times 3 is equal to 6. So my circumference is equal to 6 pi centimeters. And that is my answer. All right, now we're going to go ahead and turn the page and talk about what happens when you need to find the distance of only part of your way around the circle or only part of the area of a circle. Here on the next page it says explore. How much of the circle below is shaded? And how could we find the area of only the shaded region? So if I zoom in on this circle, I have ACB is shaded in green, and it says that it is 90 degrees in measure, and our radius is 1 meter. So if I'm trying to find how much of the region is shaded, then I need to think about how many degrees are inside of a circle altogether. And a circle altogether has 360 degrees. So that means that 90 out of my 360 degrees is shaded. So I have 90 over 360, and that is equal to 1/4, which you also could pick from the picture if you knew that 90 degrees was 1/4 of 360. And that is the same as 25%. Right, so this worked to figure out how much of our circle was shaded. If we wanted to figure out how much of our area was shaded, then we could find the area of the circle and multiply that by 1/4 to get the area of the shaded region. So we can actually write that out here. So that would mean that the shaded area would be equal to the circle area times the fraction of the shaded region. And that shaded region actually has a name. That's called a circle sector. And we'll label that in just a second. All right, so that works for area. We also can do that same thing for the circumference. If we want to find the distance of only the piece that is shaded, so the distance from A to B, instead of the distance all the way around the circle, then we can find the circumference and then take 25% of that circumference, and that will equal what we call the arc length. So arc length is equal to circle circumference times the fraction of the arc, which is that piece from A to B in our circle. So let's go ahead and add that in so that it's a little more clear as to what exactly we are talking about. All right, so to label our pieces from our formulas here, this shaded region is what we call the circle sector, and then this distance from A to B is what we call an arc, and the length of that would be arc length. So in general, we have this formula that says the sector area is equal to pi times r squared times the number of degrees out of 360, and then arc length is equal to 2 times pi times r times the number of degrees out of 360. And this is what we call theta, and it represents the given measure of the circle sector. So we have the area of a circle times the fraction, the circumference of a circle times the fraction. All right, let's take a look at a few examples. So example 1 says to find the area and arc length of the shaded region below. And this shaded region goes from J to H, and it is labeled as 131 degrees, and it has a radius of 12 meters. So now I'm going to take that and I'm going to plug it into my formula for sector area. So my area will equal pi times the radius, which is 12, squared, times my fraction, 131, out of 360. And that is what I'm going to solve. I'm going to simplify it before I plug it into my calculator, but I will have to plug it into my calculator because we have pi. So we have 12 squared is 144, so I have pi times 144 times 131 out of 360 degrees. This is all just going to be typed right in my calculator. So I have that my area is approximately equal to 164.62 meters. And that is sector area, so that should be squared, meters squared. All right, now I want to find my arc length. To find my arc length, I have that formula that was equal to the circumference of a circle. So I have 2 times pi times my radius, which is 12, times my fraction, which will be the same from area, which is the shaded region, in degrees, out of 360. So that's times 131 out of 360. We're going to simplify this as much as possible, and we're going to plug it into our calculator. So I have 2 times 12, which is 24, so I have 24 pi times 131 out of 360. And when I plug that into my calculator, that gives me that my arc length is approximately equal to 27.44 meters. All right, on to example 2. This example is asking us to find the length of GH. So GH is right here. My radius is over here. My radius will be the same no matter where it is on the circle. So my radius is 6. I have G to H, and it's labeled as a 40-degree difference. So that means that if I'm trying to find my arc length, the distance from G to H, then I need to use my arc length formula that says that we have 2 times pi times the radius, which is 6, times the number of degrees given for the sector out of the total number of degrees in a circle, which is 360. So this, I'm going to simplify a little bit. 2 times 6 is 12, so that's equal to 12 pi times 40 out of 360. The zeros actually will cancel each other out, so that's 4 out of 36. And that is much simpler, and we could actually break this down a little further if we wanted to. Really what this all simplifies down to is 4/3 pi. And I know that because 12 goes into 36 3 times. So this actually would simplify down to a 3, and this would stay the same. So this really is 4/3 pi. And when we calculate that all out, that gives me that my arc length, or rather the distance from G to H, is equal to approximately 4.19 meters. All right, and our last example, we have example 3 here. It says the minute hand of a clock with radius 9 moves from the 12 to the 4. What is the distance traveled by the tip of the minute hand? All right, so it might be helpful to draw a picture of a clock before we start solving here. So I have this clock, and you go from 12, 6, 3, 9, 1, 2, 4, 5, 7, 8, 10, and 11. Okay, there's our clock. And our minute hand is traveling a radius of 9 from the 12 to the 4. So this is the distance that we are finding for our sector, and this is the degrees we're looking for. So this is going 1, 2, 3, 4 out of a total of 12 pieces around our clock. So we have 4 out of 12, which is equal to 1/3. And that's the fraction that we're going to use in place of our degrees. So in our formula, we had some number of degrees out of the total of 360. We don't know how many degrees we have here, but we do know that it is 1/3 of the triangle, or sorry, of the circle. So now I'm going to take that and I'm going to plug it into my arc length formula. So arc length is equal to 2 times pi times my radius, which it gave us is 9, times my fraction. This is where your degrees would normally go, but this time we have 1/3. 9 divided by 3 is 3, so I really have 3 right here. So I have 2 times pi times 3, or in other words, I have 6 pi. When I multiply 6 times pi, that gives me approximately 18.85 centimeters. So that means that the distance traveled by the tip of the minute hand is about 18.85 centimeters. All right, that is where we're going to stop today. We'll pick back up with section 3, which covers a little bit about composite shapes and finding area and the coordinate line.